Alright, time for another draftphysics.com video presentation. Yes. Uh, okay, so Ian Gosling has made some sort of challenge video. And in it, he's sort of implying that somehow I haven't already articulated all of this and already stated my predictions overtly. So this is a thing with the opposers, is to make some kind of claim that I'm somehow not taking account for what I'm saying, that somehow I haven't said it overtly enough. So anyway, what I'm saying is, let's just go right all the way to what you might call the beginning. Okay, I am saying that MV, okay, is closer to the truth, okay, than, and it certainly doesn't equal 1/2 mv squared. Okay, v times v. That's silly. What that means is that I'm saying that one atom going 1,000 miles an hour is the same. They can be converted. The pressure, the impact on the universe is exactly the same as 1,000 atoms, okay, applying one velocity of pressure. That these two entities are the same, and that this entity, okay, the one atom going 1,000 miles an hour, is not 1,000 times, okay, more powerful. It's not 1,000 times more energy. It won't light 1,000 times more bulbs. It won't knock down 1,000 times doors. Now, the argument can be made, all right, let's just say that the momentum numbers always, I would say that what I've mentioned previously in videos is that you would get a momentum number, say, of 300 foot-pounds, and then you'd find out that the 1/2 mv squared came out to a number like 600 joules. And there was always this 2-to-1 relationship that seemed interesting. But not squared. Squared is different than twice as much. So I could argue that the MV is incomplete. Okay, and it doesn't tell the whole story because of the conversion difference. The difference between pushing something in the same direction, that is, hitting a light object into a heavy object, and you end up with two objects going in the same whoops, that's the exact opposite. Heavy object into light object. Okay, and you end up with two objects going in the same direction. This ends up relating somewhat to relativity. And then when you do the light object into the heavy object, you end up with this kind of bizarre circumstance where you have motion in this direction and motion in this direction. And this is it's a little bit, I'm not going to say it's a paradox, but it does create a bit of flow dissidence. Okay, it's evidence of somewhat of the incompleteness, you could argue, that the complete theory has to explain all of these elements. But I can say right off the top of my head, right off the bat, we can say this is nonsense. You want to say that this has some character that makes it special, the one going 1,000, that's okay. But to say that this is 1,000 times more energy than that would be ridiculous. 1,000 people pushing on you with 1 pound of pressure is going to be just as substantial, okay, as one person pushing on you with 1,000. Yes, the one will poke a hole in you, the other one won't poke a hole in you, all that kind of stuff, just because of the fracturability of substances. But we're talking about the movement of atoms. We're talking about the movement of bowling pins, for example. Okay, the 1 pound ball going 1,000 miles an hour, the 1,000 bowling balls going 1 mile an hour, they're going to do the same damage to the universe, essentially. All right, that's the basic argument, that whatever this is, the squared function, is just nonsense. That doesn't happen. Okay, the gun and the bullet, they're equal and opposite reactors, essentially. Okay, I'm just saying it's just like, it's really just comparing a big bullet versus a little bullet, right? I mean, that's all you're really saying is you're putting two bullets in here. This just represents a bullet that's 1,000 times heavier than this bullet. Okay, this one's 1,000 times lighter. This one's 1,000 times heavier. You know, the gun representing a bullet, and you have an explosion. And the fact is that this momentum is the same as this momentum, and it's a bit, I'd say, crazy, okay, to say that somehow the bullet knew how to collect 1,000 times more energy, because it's the third law, Newton's third law. You're not violating it, you're raping it. You're really killing it. To say that somehow the explosion put 1,000 times more energy into the bullet than it did the gun. That's a gigantic violation. So anyway, so you see all of this stuff because, when you're doing 1,000 to 1 comparisons, or you're doing on a lever, a very dramatic comparison, and saying the heavy object over here and the very, very light little object over here somehow don't have the same capacity to create weight. Okay, so couldn't see that, but it's not that essential a drawing, frankly. All right, so that's the context. So in these arguments, there's two kinds of experiments that have been done. One's involving weight, okay, and the other one's involving velocity, I guess, primarily. Anyway, so I've already explained the gravity thing, so let's do that really quick just to say, the idea of universalizing and saying all contact is the same between forces and matter, the equivalency principle is kind of a nonsense, okay? It's not the same thing when gravity pushes on all of your atoms and when an elevator floor pushes on your feet. Those aren't the same event, okay? You're not going to experience them equally. You're going to experience them and absorb them differently. And one of them has all kinds of chance not to get the energy into you in a straight line because your feet have to convey to all the other atoms, and it's going to end up conveying some of the energy and motions that aren't up and down. Just a fact, where gravity is going to ensure it's all pretty much up and down. All right, so I guess bisecting, I'm just going to say it again. Okay, it's 9.8 meters per second. They really should understand that it's per 1 second. Okay, that's what Newton gave you. All right, it's not something else. It's 1 second. You get 9.8. Okay, something falls for 2 seconds. That happens to be 4 units of distance. So 1 second is 1 unit of distance. 2 seconds is 4 units of distance. But you're only getting 9.8 per second. So it's only 9.8 here and 9.8 here. Those two would be equal, and this would be, all of this would be 9.8. Now I've drawn it backwards, but you can get well, do it right, and then you won't have to say you have to convert it yourself. Okay, the first second is here. Okay, that's the same as this second. This whole 3 units of distance, you're still only gaining 9.8. You're not gaining more than that. You're just gaining 9.8. And you hit with 19.6. And obviously you don't have 4 times the energy here. Now, we could exaggerate this and make it even bigger differences and try to pull out, their claim that it's per foot. And I can make the feet even more exaggerated. So I've made the simple argument that if you're launching a spaceship and you want to go into space, the ideal is to get up to the quickest velocity you can as quickly as possible. Now they can't do that because of the atmosphere, so they can't really turn the engines on until they get higher in the atmosphere because they can't go too fast through the atmosphere because the heat just messes everything up. But the fact is, per foot, okay, your fuel economy gets monstrously better the faster you go. But the whole idea is to reduce the amount of time it takes you to get here, from here to here. If you took your time and went very slowly rising, you would use an insane amount of fuel because the time is going to be monstrous, that the gravity is fighting you. Where the shorter you can make the time, okay, the less 9.8 units you collect. And it's that simple. So these are predictions. These are statements about reality. And, to imply that I'm somehow evading making direct statements about how these things would come out, I'm saying, yes, you'll use per mile, your mileage goes way up the faster you can get to a location. The faster you can get to it, the less fuel you'll use to get to it. It's just a fact. Per foot of distance, the less fuel you use, the faster you go. So the faster you go across the surface when gravity's pushing you down, the less gravity you'll be affected by. So again, with the rolling object on a surface, you end up with the same gravitational phenomenon. Twice the velocity, get you 4 times the distance, 4 times plus. And it's for the same reasons. And you'll end up going half the speed here at 2/3 the distance. I mean, these are all arguments I've made over and over again. These are the arguments you need to counter and explain how, no, it didn't come out that way. This isn't half your velocity here. You're going half the speed here. Prove that. Demonstrate that. Explain that. Show that. But argue that. But you're the cowards. You're the ones running from all these arguments. You won't counter them with your mv squared theory, and certainly your per foot theory of gravity. Now, obviously, they do it overtly. They'll just keep talking about how much distance you travel, and all their equations have distance in them, when it's clear distance doesn't have a damn thing to do with it in a sense. The further you drop something, the more distance is irrelevant, because you're going faster and faster through the gravity. You're exposed to less and less of the pressure. So you could just imagine gravity as a light, and it behaves exactly the same way. You're just saying the more you're in the light, the more suntan you get. The less you're in the light, the less suntan. It's that simple. That's what you're fighting. That's the pressure. It's just like paint or light. It works the same way, and it's just about how long you're exposed to it in free fall. The only way you can collect it is free falling. You can't collect it any other way. If you're doing something else, you're rubbing against something, then you're transferring the energy, so you can't collect the light, so to speak. Alright, yeah, that's probably good enough. Well, I should get to the weight one, okay. So I'll take a pause and erase. Alright, so my direct statement has been that a 10-ton train going 5 miles an hour does the same work as a 5-ton train going 10 miles an hour. That's the simple argument. So the 10 you could just represent as 2 5s, right? I could just think of them as 2 5s, and a 5. And so I give this twice the velocity. So this has a 2 velocity, and this only has a 1 velocity. The better example is to just use the same numbers just to make it clear. So this is a 10 velocity, and this is a 5 velocity. Okay, 15 is the total. It makes it kind of obvious. Alright, I'm saying those two things have the same impact weight. You hit them onto a spring or a lever or some other device, and they have the same capacity to store energy, whatever energy is, versus however incomplete the direct correlation might be between mv and energy. It's not a big lack of, it's not a squared incompleteness. It might be a factor of 2, but we'll just wait on that one, okay? I don't think there's too much reason to doubt momentum in 99% of cases, but anyway, let's just, so that's a simple argument, okay, and the compression of a spring is just a weight. That's all springs do, is weigh things. So whether I'm moving things, that's another statement I'm making. It doesn't matter whether I'm moving down or I'm moving across. It's a weight. That's all the spring can see, is weight. It just says how much pressure you're hitting me with. You can hit me with pressure slow, 1,000 people pushing 1 pound, 1 velocity, or you can do it fast, one thing pushing with 1,000 velocity. You can put the pressure in fast, or you can put the pressure in slow, but I'll detect the pressure or the energy or the momentum. Anyway, so that's the argument, that these are the same things. So now this case, okay, we're turning this upside down. So we're putting it back into the constant force. So we're going to do this experiment, except we're going to do it this way. And so the idea is you drop you drop the 10 mass, okay, from 1 unit of distance, and then you drop the 5 mass, the half mass, from 4 units of distance. Okay, so that doubles the velocity. So you have 5 going 10 velocity, and you have a 10 going a 5 velocity. Alright, and now you're going to crash them into the spring. Now the thing you have to consider is both of these things are still in this constant force. Okay, so that's the difference between doing it horizontally versus doing it vertically, is that the constant force is now affecting the objects. Now it's affecting them in this horizontal, but it's a tiny effect because it's just the friction effect. So if you get the objects to the surface at the right velocity, you're okay, because friction can't steal any of it then. So if you're assured that you have your 5 velocity when you hit this surface and you have a 10 velocity when you hit this surface, then you're okay. Now if you did it from 10 miles away, obviously you get very uneven results, because the heavy thing is going to incur a lot more friction, so it's going to be slowing down much faster. So if they had to roll a distance before they hit the spring, well, then you're going to get messy results. In this case, the only thing messing up the results is you have to recognize that, okay, this has a motion weight, okay, the collected velocity weight, and it has its original weight. So all you have to do is recognize that, well, from this one, whatever reading you get on the spring, okay, you have to just subtract the original weight, because the original weight is part of what's going to, because it's a constant per millisecond force, it's still making weight. So the weight's still there. So you have to subtract the weights. So from this one you subtract, the 5 pounds. And from this one you subtract the 10 pounds. And then these two expressions will be the same. So the impact, it'll impact and the spring will compress more. Alright, and then it'll oscillate, and then it'll come to a rest position. That'll be the actual mass weight. So you'll have the static weight, and this is the impact weight. Alright, and this is the unweighted. And so what you want to read is this impact weight, but you want to recognize it has built into it the static weight. So you just have to subtract the static weight. So simple enough. You read your pounds here on the spring, you drop it, you read the pounds, you drop it, you read the pounds, and you subtract the static weight of these objects. Alright, that's my prediction. So again, I've never not predicted, I've never stated, there's no doubt about what I say the outcome should be. So this whole vague notion that I'm evading taking a stand, I can't even describe how insane their accusations of my misconduct are, in the sense that all I've done in all these videos is make direct predictions about the two-slit experiment, about redshift in space, all these things. I made direct predictions about why the event takes place. All right, explanations. I've gone to the trouble to see. This is what they won't do: is explain any theory of how it functions, how the little atoms can do what they claim the little atoms are doing. They won't give you any explanation for how they manifest, the energy. And certainly we don't have any simple, experiments showing it taking twice the fuel to go 4 times the fuel to go twice as fast. And that means 9 times the fuel to go 3 times as fast, something like that. And, it just gets worse and worse the higher you make the numbers because of the squared function. And then you end up with some notion that it takes 1,000 times the fuel to make the bullet than it takes to make the recoiling gun. And really, frankly, how could a reasonable person say that's in the realm of possible? How could a reasonable person say that? 1,000 times the fuel? Alright. Okay, so we'll play this piece of... these videos are all crap. I haven't even watched this A balance video. I guess we can watch that one together. I've watched half of this one, and again, it's premised so ludicrously that I shouldn't even have to take it seriously.
Time to get.
Okay, so, all these antics. He's becoming full brozo. He's got his little squeaky nose on now. He's got his funny little makeup. He doesn't have his shoes yet, but, he's working on it. It's all just a big clowny joke. Science. Ugh, it's just pathetic. Alright, so you could just explain the theory. You could just explain. You could show us a spring, and you could say, see, this spring is useful in detecting energy. Okay, he thinks it's an energy detector. And we have every expectation, that, wherever there's the most kinetic energy is where we're going to get the most spring compression. That 1,000, one atom moving 1,000 miles an hour will in fact compress the spring 1,000 times more. If we can do it, the experiment. 1,000 times. Okay.
Worried old boy.
Oh boy, Jesus. This is pathetic. Okay, somewhere around there should be enough volume. It's just these antics.
Time to get worried, old boy.
The British are coming. Yeah, I'm really scared.
The truth is coming.
Oh, brother.
You won't be able to escape it.
Yeah, whatever. Fine. Let's see the truth. Okay, yes, let's get to the part where you actually show the truth rather than rickety, crappy, shitty experiments. Let's see you do a real one. And let's see you do one other subject. For example, show that if I put a lever on the ground sideways and then I put energy in one side, the momentum doesn't pop out the other side, that the lever doesn't conserve momentum. It's a good proof. Because, frankly, I can use your proof and then go to all the conventional physicists and say, why do you keep talking about conservation of momentum? This isn't a thing. Springs don't conserve it. Levers don't conserve it. Gears don't conserve it. Hydraulics don't conserve it. Why are you talking about conservation of momentum? It's a silly thing to talk about. All the basic tools of mankind don't conserve momentum, so why do you keep talking about it, you silly little beasts?
I'll propose an experiment, and I want to sound you out first.
Oh, it's just, sound me out, right. For 2 years I've been saying these things. 2 years. He needs to sound me out.
Because I ain't got no crystal ball.
Oh, brother. It's just, you don't got no balls of any kind, crystal or not.
But we all know that you're going to have to find excuses.
So just more bullshit. I can't diagram it any simpler. I've said it all these times. I said, well, what, you think two 100-pound guys hitting you at 5 miles an hour is... in their case, less energy than one. It's the other way around, I guess, right? Well, regardless. No, that one 5-pound guy, one 100-pound guy going twice as fast is more energy than one 200-pound guy hitting you at half the velocity. You really think so? And again, I could just keep exaggerating those extremes until I get to the bullet and the gun. And they'll say that the bullet is 1,000 times more energy than the gun.
Why it doesn't work.
I mean, it's just ironic, in light of, let's say, even the Dispar video, with the carts that barely roll. Wow, why aren't you completely convinced by this evidence? I think it's a pretty good reason.
Let's have a little scale. A little fishy scale.
All this is a video, huh? Yeah, this is a science video. You're making a scientific argument. This is right up there. So you would send this way. If you disagreed with Newton, this is the video you would have sent him. Oh yeah, I'm really gonna get you, fucker. I mean, it's just who would you do this video to? It just except me, right? I'm the only person you could be this rude and stupid in terms of responding to. You wouldn't do it to any other human on Earth if they disagreed with you.
I've got a little magnet on here. I might get a better one. So as the scale moves down...
Yeah, that's good. You got a scale. Mine's made out of aluminum, so I couldn't use magnets because it's aluminum.
Down, you'll leave the magnet in place so we can see.
Super.
What reading?
Yeah, we love that, right? When Brozo did with the blob of clay, I pointed out how, yeah, that's clever, that's good. We like it. This is a good way of measuring impacts because you don't have to worry about capturing the right frame on the video or any of that other crap. You have a nice little representation of what the maximum compression of the spring was, and it's such a tiny mass that it can't absorb too much of the energy, especially when you're dropping kilogram weights. So yeah, great.
It had. I propose that we tie a weight on here.
I propose that first you make sure you mount the support for the spring has to be really good. So like the joist of the ceiling or something. It has to be an immovable object. Yeah, an unbendable.
And we drop that weight from one height.
Yes, 1 unit of height of unspecified amount. Could be a centimeter, could be an inch, doesn't matter. So yes, let's just say an inch for the fun of it, just to reminisce about the olden days.
Take a reading. We can hang the weight on a bit of string, say.
So the irony is that we really don't have a great example of the 1 to 4 thing. So you might as well just do that first. Just take the same weight, drop it from 1 unit of distance, and then drop it from 4 units of distance, and see if you get what you're supposed to get, which is twice the velocity. Yeah. Indicating,
We can drop it from one height. We call that one velocity. Then we get half that weight. And we tie it on here, and we drop it again from 4 times the height.
Right. So again, you could just use the same weight because all you know is that it's supposed to just double. It's only twice the velocity. Did the weight double or did the weight quadruple? Because you're claiming 19 is 40. Okay. I mean, your theory really should say it should be double the amount of energy. So it should be double the spring compression of the other, 4 times the compression. Double the twice. Double twice is 4. So I didn't want to confuse you.
That's twice the velocity. Even you agree. And your theory...
Yes, my theory is the football player thing. The 10-ton train going 5 and the 5-ton train going 10 would hit the spring and create the same compression. That's my theory, yes. The theory I've argued for 2 solid years, almost every day.
You're one and only in the whole wide world.
Right, so the rest of the world thinks that the 5-ton train can move 2 10-ton trains 5 miles an hour. It has enough energy to actually equal the pulling force or pushing force, right? Whether we do a tug of war or we do a smash into each other. If I smash them into each other, the 5-ton train has twice the energy, so it really should just plow right through that old 10-tonner. You know, the 10-tonner should be just, the shit should be kicked out of it. Just twice as much energy. That's your theory. And then if they're in a tug of war, the 5-ton is just so powerful, it's going to drag that old 10-ton right off the tug of war field. Yes, I've been making that argument for more than 2 years, almost every day. And they're making this moronic video. So you wait 2 years to finally get to the subject, and this is the fucking video you make? Amazing.
Theory that MV is energy. They should both read the same amount.
Yeah, both. About the same amount. Yes, and minus their standing weights. You have to take the constant force out. So the difference between this experiment and the sideways experiment is, in one experiment, gravity is going to be the source, and it's a constant force. So and the other one, you're just going to propel the objects with those velocities, and there's no constant force involved. So one of them has just the impact pressure sideways. That's just impact pressure. That's just mass and velocity. The other one is mass and velocity plus weight. So you have to subtract the weight.
Shouldn't they? And I predict that if kinetic energy is right.
Alright, so it's kinetic energy. It's twice the energy by your theory. So you should get twice the compression. Not 1.4 or any other kind of numbers, right? It should be twice.
The half mass, twice velocity will read a bit more.
Not a bit. No, it should be twice the energy. So, I mean, if you believe in Hooke's law, so again, are you going to pretend Hooke's law isn't real? You're putting in twice. I mean, how can you say twice is only a bit more? What the fuck? That doesn't make any sense. If it has twice the energy, it can't be a bit more. So you're saying the scale doesn't measure energy. So, okay, that's what you're saying. It doesn't measure energy, and you're just doing the experiment for the fun of it because you don't think the results mean anything because it doesn't really measure energy. Okay. No, that's not okay either. So what is your exact prediction? A bit more? What's the exact, what? You can't do better than that?
Doesn't matter how much more.
Yeah, it really does matter. It matters a lot. But anyway, obviously I'm arguing likewise. Okay, see one number, the 10 mass number, you're going to subtract 10 pounds from, right? And the 5 mass, you're only going to subtract 5 from the compression. So the fact is the 10 mass will compress the spring a little bit more because you're going to subtract the weight out of that number. And then once you subtract the number out, the impact velocities, the impact of the motion will be subtracted from the standing weight, the static weight, and therefore you'll be just measuring the impact energy, not the energy of the mass itself. I mean, obviously, in a way, the mass itself has energy, right? I put mass on a scale, okay, and all I do is do this sideways motion, and somehow the scale goes down. So just the mass by itself impacts the scale. You have to subtract that part from the bang part.
Just that it reads more means that there's something wrong with your theory. What do you...
No, so let's just say it's a 2-year theory. I've been rather explicit in what's going to happen, and he's saying it's to be off by a little more factor. So, nothing about the theory of springs, nothing about how any of it. So it's just this is so, it's just evidence of people, again, people accuse me of believing in a conspiracy theory, and I say, no, there's no conspiracy, there's just idiocracy. And that's all it is, right? It's just, these are idiots. The planet is covered with idiots. Idiots believe silly shit, and this is what you're stuck with as their argument. This is how he's going to prove Jesus exists. It's obviously not a very good proof.
What do you reckon? Are you up for it, Gary?
I have been begging for experiments to be done, okay? Better than yours. That's what I've been begging for. Oh, it's just amazing.
Or should I not bother with all the effort of it? Tell me.
Whatever. What I've pointed out over and over again is, why don't you just get to it, okay? If you want to prove springs don't conserve momentum, okay, do that. There's lots of experiments you can do to prove the spring doesn't conserve momentum, so prove it. All right, do the twice the velocity thing and just show the spring doesn't work. Hooke's law is a piece of shit. Go ahead, prove it. All right, and the same with levers. Show a lever not conserving momentum. There, done.
Now. Come up with your complaints now. I'll give you some time to think about them. What could you say? Well, is air resistance on the weights dropping?
So I've repeatedly pointed out how, air resistance is negligible in most experiments, but I have also pointed out that there's a big difference between a frisbee and a baseball in how it goes through the air. Okay, big difference.
Springs dodgy. If I did it multiple times and there was a variance in the reading, you would say, well, look, it's inconsistent.
Variance in the reading. So again, he's being so inspecific. He claims there's twice as much energy. Why don't you explain why twice as much energy doesn't mean twice as much compression? That's all. I mean, just explain that part to me.
If there's any consistent difference, doesn't matter.
So I guess he's obviously already done the experiment, right? He's doing his little I gotcha thing or something. There's not going to be any I gotcha, okay? It's just going to be this typical shenanigans. That's all they have is shenanigans. They can't make a straight up physics argument. They can't make one in a decent scientific way. They can't make one that would be at all an advancement in understanding. All they can do is this cheap, crappy ridicule nonsense.
No matter if it varies, but if there's a consistent difference in the two, that...
So again, that isn't what we're looking for. Okay. And frankly, we're looking for an affirmation of your theory. Your theory is one has twice as much energy. It should display that twice as much energy on the energy detector. The energy detector should detect that it has twice as much energy. You have to explain why it's not detecting the twice as much energy. That would be helpful.
Will prove that kinetic energy theory is correct. It's giving you more energy
than
just mass times.
Okay, it's not velocity. Just more. So again, he just keeps playing a game. It's not just more energy, okay? mv squared is a specific number. And in this case, the number is twice the other number. It's not some amount more. It's twice as much energy. So I should see twice the effect. So you have to explain why I'm not seeing twice the effect. You have to come up with some kind of rationalizations, like, well, the cars couldn't crush anymore, and well, the clay can't squeeze out as easy. When you squeeze half of it, the second half is harder to squeeze out. So you have to make up some kind of crap, okay, to evade the truth. Jeez, you're just such an asshole.
Do you agree? Are you brave enough to find out the results of the experiment?
Yes. So he's, like I say, he's already done the experiment and he's playing this game. Oh, about his courage. Hilarious. Oh, God, what petty humans.
Let me know.
Fuck you. I shouldn't even play these videos anymore. I mean, this is just such crappy rhetoric. Ugh. It's beneath any human to have to tolerate. So the John Walker has provided some kind of wacky numbers. So he's conceding that the momentum will be conserved. Now, that's kind of stupid, right? Because frankly, I don't know. So, okay, they're still arguing that springs don't store momentum. They don't read momentum. So even though I could make the argument that, gravity is pushing you at the same velocity for all the masses, and it just adds, you collect more of the same speed. It's 9.8 meters per second. We're all collecting the same speed. And what we're going to do is collect different amounts of that based on the size of your mass. And that's what momentum is. And so it really is just so tied to being weight. I don't know how you could separate the two things. So if you're going to say it conserves the momentum, you really have to say it. Yeah, it's conserving weight. But anyway, it's okay. Let him go ahead and believe that. And so he comes up with numbers of 410 and 292. Okay, so that would be a 3 to 4 relationship. So clearly not indicating anything doing with any squared amounts here. Certainly it's not twice the compression, far short of twice, okay, that you would expect, frankly. Twice the velocity, twice the kinetic energy of, it should be twice the compression of the spring. If it has twice the energy, it should compress the spring twice as much. So he's not predicting that. And regardless, as this idiot has already done the experiment, he's already found out that there is a difference. And as I explained, the difference is just the standing weight difference. You have to subtract the static standing weight from the weight number. They obviously weigh different amounts, right? So if I put them on a scale at 10 and I put a 5 on the scale, obviously there's going to be a huge difference in how much they compress the scale. That's already built into the impact weight. The impact weight includes that extra cheat, so to speak. So you have to take the cheat out. The standing weight has to be subtracted. And then you'll see what the velocity and the mass as motion are adding to the weight of the object. See, the objects weigh 10 pounds. It weighs 10 pounds, whether it's here or here or here. Wherever I put it in space, it still weighs 10 pounds. It still has 10 pounds of mass. And if gravity is a constant force, it always weighs 10 pounds. It's just that you're not measuring its weight. To see its weight, you have to measure it. That's the trick. But it still weighs 10 pounds. All right, and you have to subtract that. All right, oh, a Piro comment. Well, let's see what these replies are. Okay, John, we will try it. So he's pretending he didn't already do it. Okay, it's kind of funny. Also, I have a request, Ian. If you video the scale when the probe is moving to its lowest point, you can wait till the needle stops moving, because that would be the weight of the probe. Yeah, duh. Duh. Yeah. This Spar didn't do that in his video, but he measured the weights on another scale. But for some goofies might think there was some trick involved, you see. The trick is making sure you have the right velocity. So how you drop things is, part of the game. It also looks ninth to have everything in one shot. Oh, I guess that's nice. Another tip I want to share, oh, that's such an arrogant douche, is, this is a free energy nut, by the way. He thinks hot chili peppers are magnetic. Is that after the, whatever it is, screw or measure ends at a certain value, repeat the run without sliding back up, because it might slide just a little bit further down the second time. That would be, frankly, the Brozosian method, and that's really stupid. You always want to put it back and get the actual reading, because then you're just going to be measuring the maximum. So you'll have you'll just have one worst case, and that's it. So instead of removing errors, like finding, you get the answer 8, and then you get the answer 7777, and then you get the answer 6. You want to kind of kill the 6 and the 8. You don't want to keep them as the result. Moron. God, he's such an idiot. Teachers would tell their students to keep repeating the run until the screw measure doesn't slide any further. No, they would say exactly the opposite. That would be ridiculous, because then you only collected one error, and that's all the information you got. You did 10 runs, and all you did was collect information from the one worst case. And that would be too stupid. Oh, he's so stupid. It's just, no, I shouldn't have to read these comments. They're so stupid. Okay, so Piero says, okay, this is funny. Okay, just one thing. It's not going to measure the impact force. Why wouldn't it do that? I mean, it can't avoid the impact force, frankly. Okay, it just can't avoid it. The spring is in the way, it's going to measure it, because that's the force it has at the start. So that really makes no sense. When the spring force is 0, there's no spring force that's relevant, frankly. You're just, adding energy to the spring by compressing it. As it compresses, the spring force goes up. Yeah, it doesn't matter. The spring force going up is just evidence of the fact that the energy went in. Okay, reducing the speed and effective force of the object. So none of that happens. Okay, the spring does collect the energy, and then it gives it back again. So I throw a ball into a spring, and the spring compresses, and it throws the ball back at the same velocity, hopefully. Right, none of these things are as good as we wish them to be, right? I mean, springs are only like, 85% efficient. Who knows? Nobody's doing those experiments either to test the efficiency of these objects in terms of being able to capture energy and release energy. So we know, like, batteries aren't perfectly efficient either. They get hot, they do a lot of things that are ruining their efficiency in storing energy. So we lose some putting the energy in, we lose some getting the energy back out again. Springs are likewise susceptible. But again, I don't think the number's much worse than 85% anyway, or 90%. I think there are springs that probably can do better than that. So it's just silly to say that there's some place where all of the energy is disappearing. It's not. The spring is pretty good at making relative comparisons. That's why Hooke's law works, and we're really looking for a relative comparison. Both spring compression should have the same losses. That's what Hooke's law basically is saying. As soon as the spring stretches, compresses, it reducing the effective force that the object's downward momentum until it goes down to the object's weight and oscillates around that. So, this doesn't even say anything. Obviously, the impact, the added weight, we're adding to the weight velocity. So we're taking a weight that weighs 10 pounds already, and we're giving it a velocity. It's not that complicated. And we're saying the spring is going to now collect the motion of that weight, and it'll see that as momentum, the momentum portion. And we just have to subtract the weight. Okay, so how to calculate how far it will go down is difficult. So I'm sort of arguing it's not very difficult. You just measure how much the spring compressed, and you just subtract the compression distance of the weight itself. And that's all you have to do. I'm not sure what to expect. I mean, obviously a 10-pound weight, if I drop it, if I move it at all, it's going to weigh more than 10 pounds, right? So I could drop it and it could weigh 11 pounds. I could drop it and it would weigh 15 pounds. I could drop it and it will weigh 20 pounds. We're just interested in the portion of the extra, okay, that is the motion part, not its weight part. All right, so in the case of 11, we'd be looking for the 1. You know, in the case of the 15, we'd be looking for the 5. You get it? You just subtract the weight, and then you see the impact weight. The weight produced by the impact. The motion. All right, so that was pretty funny. I mean, Pierre was basically saying, I don't have any idea how this works. Okay, but you think the basic idea of there being a difference and not the same reading should prove that MV does not give the right answer. So again, they just keep talking like this, and it's just hilarious in the context of their theory says it has twice as much energy. Okay, the 5 object dropping twice the 4 times the distance has twice as much energy. That's their theory. Their 1/2 mv squared formula says the lighter mass going at the faster velocity has twice the energy. And they're saying twice the energy should come up with some little difference. If there's any difference at all, that proves mv squared. Any difference. Doesn't matter how much. Yeah, we don't need to be twice as much. Why would we have to be twice as much? Is twice as much energy in? Why should I get twice as much energy out in the compression? That shouldn't happen. Pathetic. Okay, novel setup ion. What is novel about it? Well, I mean, the magnet is a nice little trick. I wonder what the hell he'll say to this. So I've been saying it for 2 years, and they're going to imply that there's some, oh, we couldn't predict what Gary's going to say. She's been saying the same thing for 2 years, and they can't make that prediction. Their predictive skills are pretty limited, I would say. They're pretty poor scientists if they can't predict this one. Okay, we make a stand-up prediction. So again, all my videos are stand-up predictions. I mean, every single one of them is a direct assertion. Okay, or just weasel his way out. And the evidence of the weaseling is what? You mean the clarifications? Oh, so I'm weaseling it out because I can understand the difference between moving football players across a field into blocking dummies and dropping objects in gravity. Because I can make a distinction between those two things, like the experiment will come out a little bit different. Oh, that's a weasel. Okay. Will be interesting to see how he chooses to proceed on this one. So just more of this. Checkmate me reckons. So they really just don't care. These guys will never have to see it taking 4 times the fuel to go twice as fast. You'll never have to show them anything. They'll just believers. They have faith. Ugh, disgusting. Well, thanks, but he has been using the excuse, oh shit, of slight inconsistency. Where's this? To dismiss evidential proof regularity. Yeah, you're trying to measure something that has a 15% difference, okay, in the value. And let's say you have a margin of error of 10%. That's pretty bad, frankly. Anyway. I know it. May others know it. The strangest part of all is he knows it and knows we all know it. So I know that, again, the 5-ton train wins every battle with the 10-ton train. No, we've never seen any of those battles. Well, we have in one case. I mean, Toady did do the battle. Okay, he opposed the 5-ton train against the 10-ton train. And guess what? The collision didn't move with the 5-ton train. 5-ton train didn't win. but that evidence doesn't mean anything to these turds. Few that he was a lot of no's. That was just a lot of no's. I don't know. Yes, it was pretty inarticulate. So even there's no way around it. These people can't speak or write very well. I know, you know that. Oh, that's so clever. So anyway, moron. Yes, so we've heard from the morons, except for the brozo. No brozo statement about what weight is. I did my 53 car crashes and blah, 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 they all prove blah, blah, blah. Yeah, we missed out on that part. Okay. And certainly 14 does equal 16. I'm quite sure of it. I mean, there's every good reason to believe 14 is exactly 16. That's Brozo's theory. Alright, so that was just horrible. So now we'll go play the other piece of shit. Yeah, what the hell. Alright, so this one we're back on the lever and the oscillator. And again, I just made the simple point that whatever the cause, okay, of oscillation in a lever, whether weights can be applied to the top of the lever or the bottom of the lever, both configurations can be turned into a working balance. And he's claiming that he has proven some geometric reason why it's not possible to have a balance, okay, by applying the weight to the top of the lever. And clearly the Chevrolet clip I showed the weight being applied to the top of the lever.
You feel indestructible when you're younger. When I was in my 20s, I felt like, you know.
Yeah, it is disgusting. Golf. My favorite sport.
Superman, like I could do anything and everything.
About 7 years ago, I injured my right knee.
Oh, well, that's, lose some weight, Bubbles. Anyway. Doing what? Running to the donut dish? Sorry. I mean, it's one thing, well, whatever. There's probably no excuse for any of us not being perfectly safe all the time and preventing injuries. No excuse at all.
Chase's video.
So that's essentially the configuration of my lever. Okay, the weights are hanging down. All right, and but they're not tied. So this, tying is tricky. Where's the pressure actually being applied? Is it being applied to the bottom of the lever or the top of the lever? You'd have to say if it's tied tightly, then it's the bottom of the lever. If it was just a hook hanging over the top, then you would say it was applied to the top. So he can't, he won't even do this top-bottom thing in some kind of rigorous way. These are obviously not dangling from the top. They're dangling from some point he's fixed at the bottom. So these are bottom danglers. But that's what mine did. I just had magnets, so it was stuck to the bottom. So obviously the pressure of the weight was at the bottom of the lever. And the Chevrolet one, the hooks went over the top of the lever, so the pressure was on the top of the lever.
Chubby Chaser?
What? I don't know what this Chubby Chaser thing is. I don't know. What the fuck are you talking about?
Call it.
What a kook.
Chevrolet. This is what...
So Chubby Chase has something to do with Chevrolet? I don't know. What the fuck are you talking about?
They've got, I believe...
I mean, you probably need a little more volume here.
Weights, free to swing. I've got elastic bands hung over the top of this rod. Much narrower now.
Okay, so there are pushing on the top on an elastic band that goes across the entire top. So it's really the pressure is not just on the top, it's around the sides, and so it's really pulling from the center of the lever, technically. I mean, I think that would be the technical fact, is that the substance of the pressure is being applied to the sides of the lever.
And it will balance. I've got just a nail.
Yeah, so it's almost balanced. You need to move that one weight in just a little bit.
Interestingly, it tends to balance whatever displacement you put it in.
Yeah, that's sort of my point. That mine won't do. Okay. So he's got the lever really screwed up. Mine doesn't do this, frankly. So again, we're back to this argument. This is a tiny amount of energy differential. So understand, when you're not hitting the lever, you're just putting in this tiny bit of energy in terms of displacements, and the displacement energy is very little energy. And that's when the fulcrum matters. That's when any friction in the fulcrum. So I would argue that the only reason why this lever is staying in that condition is because there is enough friction in that bearing that it's just not enough energy to push past the friction. But it really would balance if it was a really good bearing, or if it was a pointy fulcrum.
Doesn't want to oscillate. I have no argument with what they showed.
I don't know how you can't have any argument with it when you're explicitly saying you can't have the weights attached to the top of the lever. That geometry means that you have a unstable balance. That's your argument. You're called it stable. I'm just saying it's unstable in the sense it's not a balance anymore.
These are hung over the top, as you say correctly.
Yeah, that's the part that's a little bit because they're stuck to the entire surface. Obviously, the hook can only hit one point. I put the square. It was a square hook. I put a square hook. It can only push down on the parts it hits. The rubber band is covering the whole round surface. You should be able to concede they are a little different.
So what you're saying is, because of my picture with my wide lever,
what I was saying is this is such a little nuanced piece of shit subject that, frankly, do we really have to go over this? How does this have anything to do with whether levers conserve momentum or conserve 1/2 mv squared? I mean, how the fuck does this have anything to do with the subject?
I hung the weights here. Any displacement, it was unstable and it would turn over. It doesn't do that in this case because we're reducing the width down to somewhere near the axis of rotation. The narrower you make it, the less likely it is to
Yeah, that's exactly what I said. You're exaggerating it by making the giant lever, and the whole effect changes once you get rid of that. But that still doesn't explain why your balance isn't balancing. That's another subject. I mean, taking it and putting it out of balance when it's called a balance for the reason that it's supposed to balance, all right? I mean, he calls it in balance when the lever's like this. He's saying it's in balance. Well, I mean, no, obviously this is balance. Balance should do this. Balance should show they are the same, not that there's an inequity. This is like the needle on your measuring device, and if the needle's not in the horizontal position, it means it's not balancing.
Less differential there is.
I mean, that's how bad this is. We can't get any words used in a common way. Balance means that's straight across, and he's saying balance means crooked. And then he's using the word stable is when it swings all the way around, and unstable is when it balances. It's just hopeless.
Force time arm. So the more stable it becomes. This would be shown on the drawing I did as well with the geometry, force times arm. I expect you'd argue about this.
Yeah, I'm just going to argue that this is nonsense, okay? You're basically, by your theory, the two shouldn't behave anything like each other. Applying the mass from the top should be very different than applying the mass to the bottom. You should get a different result according to your geometry argument, because the two have exactly the opposite geometric effect. Okay, the top produces an opposite effect from the bottom, and therefore they should have opposite reactions, when in fact they both can perform the same. And that's what I'm arguing, that they both work as a regular balance. Either way works. So that geometric explanation can't be the whole story. It's an incomplete or broken theory.
Probably forced me to draw it all over again.
I wouldn't do that, okay? I'm still going to ask the question, why the fuck should anyone give a damn about this fucking little nuance that if you have the masses right through the center of the object, blah, 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 it doesn't balance? We're talking about a scale, okay? Used to measure the weight of two different fucking things. We just want a scale that works, okay? So we know for 1,000 fucking years, if you dangle a little net down here and you dangle a net below this side, you can make a fucking scale that will measure two fucking things and make a comparison between their weights. It's a fucking scale. We just want to use it as a scale in this case, you fucking idiot. Jesus Christ. This fucking bullshit argument about this completely irrelevant technicality. It has absolutely nothing to do with whether I have a balance lever that works, a scale, and whether I bang this scale with energies, whether I can compare the weights of objects, the momentum of the objects I have now attached to the lever. Does the lever conserve momentum? Is the simple answer. Does a weight applied here create an equal weight on the other side?
And then they think, what's the point? Because you don't take in what somebody's showing. You're just interested in arguing about it.
Oh, again, fuck you. You're just interested in arguing about it. I'm saying I just don't give a shit one way or the other, okay? And I'm just pointing out that, well, if you're going to propose a theory, it has to have consistency. So I'm just pointing out how there's an inconsistency in your theory. But I don't give a fuck. Again, this whole rotating bullshit side subject is your Ambroso's little fantasy. That somehow you prove it's mv squared because you can make a lever spin or some other kind of crap. Or you can make it oscillate out of sequence or some kind of crap. You think that's highly significant. I think that's just a waste of goddamn time. Why don't you just plow the 5-ton train going 10 miles into one side and see if it'll produce the 10-ton train on the other side and vice versa? Why don't you just get to the fucking point? Does the lever conserve momentum? Why don't you just get on with your business of proving it doesn't? Because that's your theory.
It's all to do with this line of action through the pivot and a perpendicular through the line of action of the force, and it's where that weight is hung. The nearer the point.
Obviously, everybody agrees that the closer it is to the fulcrum, the fact is it gets lighter and lighter, and the further away it is, it gets heavier and heavier. The mass is multiplied effectively, and the weights. So a 5 out here can weigh the same as a 10 here, and they weigh the same. And my simple argument is weight is momentum. And if we oscillate it, we'll see the momentum. We'll see the object, the 5, going twice the velocity that the 10 goes. And so we'll see a perfectly consistent result that's showing these are equal amounts of momentum, that it's producing equal amounts of momentum on both sides of the lever. Now, clearly, when you hit it, it sort of has to be the same, because you have the momentum of one object moving in rotation, and you have the weight of another object moving in rotation, and the impact weight is going to be the same on either side of the lever. But we're talking about, is it theoretically possible that they could oscillate, and then I go just that little bit faster to create a detaching velocity, so the lever goes slower than the object, so now the object will leave the lever, or I put a stop on the lever so it can't move anymore. The object's already moving twice the speed. Can it now slow down and not go twice the speed? That's the simple argument. No, my theory is no, it can't slow down and go something less than twice the speed. It's not possible for it to do that.
Of where the weight is acting to the centre line, the less it wants to move. I'd have to draw a picture really so you can see it a bit. But I just wanted to say, yeah, that's right, it will balance when the weights are hung on.
Okay, so again, he's using this, he's calling this balancing. It's completely not balancing. So what are you talking about? So there's three subjects here. There's this that he's calling balancing, which is out of balance but static. And then there's it can't do anything but swing around. It's completely, it doesn't work as a balance. It's so unbalanced. I don't know how to even say that, but the weights are so disproportional and out of control in terms of how they're changing or something that it can't show you. It can't be a scale anymore. And then there's where it works like a regular scale, where you can just put a little bit of pressure in over here, and you get and it oscillates perfectly. The further out you go, the more momentum the lever has in terms of those specific atoms. And the argument is simply, my argument is simply, that you really can't change the fact that it has to conserve momentum. The 5 mass can't, this far out can't weigh more or less. It can only weigh the 5. But whatever.
Top, but it's because of the much narrower lever. And
so the simple argument is you have a straight lever, right? And you put energy in one side at specific locations where there's this lever ratio, that twice the distance, doubling of the weight, effectively. Just go twice as far from the fulcrum, you double the weight, double the weight, double the weight. Okay, so the same mass can weigh lots of different weights by how far I put it out. And that if I just put any kind of energy in, I have to get twice the momentum. The momentums have to be the same. One side of the lever produces the same momentum on the other side of the lever. Levers conserve momentum. That's the simple argument. Okay, all of this abstraction is not on the subject, frankly. But this is how they do physics, right? So you can make this as a comparison to what they did to the Eddington experiment, where they said, oh, well, we have all these other experiments that confirm. Yeah, but every single one of the other experiments have nothing to do with optical resolution, and none of them have anything to do with being outside the corona of the sun. So, it's a game played.
well, if you'd like a picture, I'll draw you one.
No, I'm saying first tell me how this is relevant and how this proves that 1/2 mv squared moves levers. But he won't do that. Alright, what is this, Alexander? We haven't seen that asshole in a while. Let's see. And he even figured out the reason for the instability, namely the ability to center the mass of the assemble to be lowered. He played videos of Julius Summer while commenting as much, meaning that the weights are on top. It is unstable because it can still fall while fixed in the pivot. Yeah, it has somewhere to go. If the weights are in the bottom, they can't fall. Yeah, and if they're at the top, yeah, they can fall. That's a simple explanation for why the center of gravity thing works. While you simply refer to the geometry, which draft science is an invalid explanation. which drafts science is an invalid explanation because the geometry is identical if hooked below the pivot. It's really not identical, but whatever. The whole point is it's not the same. The geometry is what we are referring to. This arm is longer than that. Position of both arms are the same. I don't know why this is not a very... The arm is smaller on one side and longer on the other side when weights are hanged in the lower corners, yet it is stable. Draft science got to the point you did not. What it has to do with the center of mass being able to go lower, yet you are so belligerent. Okay, well, it's a defense. The simple point is that the theory isn't consistent, okay, with the fact that it doesn't always apply. And the basic argument I was making was that, yes, Julius Sumner talking about, in a rather boring video, but whatever, about center of mass, it's really has more to do with the center of mass than it has to do with any geometry. Even though geometry is the center of mass, is geometry. But anyway, thank you for taking the trouble to comment. Unfortunately, you're wrong on every point, so I wouldn't know where to begin. Okay, so that's his evasion. I suppose you could start by making a video stating that I am wrong on every point, then insult me like you do draft science. You may find this in your nature. The ideal would be a real discourse. Yes, that would be the ideal. But anyway, that doesn't happen. Did you watch Why Balances Oscillate or Not? Oh, that's one of his own videos. Did it make sense to you? So that's the whole point being made, is no, of course it doesn't make sense because it's not consistent with the actual experiment where the experiment works. They use the weights applied to the top and make a balance out of it, a scale. I believe I have, you go along with that question, I don't know. I will point out that video came after draft science concession, which you failed to acknowledge. In this video, he browsed your channel to see what had any more videos at the time, and that one was not up yet. Alright, well, whatever. So yes, I clearly conceded that apparently if you put the weight inside the lever can't see it. Okay. I want you to watch it and tell me if you understand it or not. Forget Gary, he can defend himself very well. Generous as I am, I will consider your questioning of my understanding, and so come to conclude that you interpret stable meaning weights hanging, applying the same force on levers as would be if weights are perfectly aligned with the pivot of the lever. So again, yes, the fact that he's using the word, look, it's perfectly balanced, when it's not balancing, is problematic. All right, so let's not bother with this. Let's see what the ending of it is. Oh, Mindless Marbles chimes in. I will point out that video came after Drive Sound's concession, which you failed to acknowledge. You are correct. However, Ian pointed out that the center of mass determines the behavior 3 months prior to his first video title, Oscillating or Static Balance. And again, so how does any of this, again, I mean, I don't think I would ever say that, oh, of course, if you put something above, that it has the same ability. I mean, like it's hanging something below has the same capacity to create errors. Of course it doesn't. Hanging below means you can't really fall. All right. Gary has finally figured out what we were trying to tell him 3 months ago. No, I haven't figured that out at all. I still don't see how this has anything to do with the basic subject, which is, do levers conserve momentum? So how have you proved they don't? Why are you praising Gary for something he took 3 months to figure out? So this is kind of a joke. There's nothing here, right? I mean, again, they're saying that because he can create these different levers that oscillate at a different rate, he's claiming that means that 10 pounds doesn't weigh 10 pounds. That if I put a 5-pound weight 2 units of distance, I can tell the difference between a 10-pound weight 1 unit of distance and a 5-pound weight 2 units of distance by just touching the lever and pressing on it a little bit. You know, not oscillating it all through a whole motion, but just, you know, pushing on it. And I can tell the difference. And I'm arguing, no, you can't. And I'm saying the same thing about gears and other things that have essentially levers in them. That, no, if it weighs 10 pounds now, it weighs 10 pounds. It can't, 10 pounds is an amount it weighs. It can't weigh 9 pounds. It can only weigh 10 pounds. That's the part you haven't figured out. That it's kind of nonsensical for you to say 10 pounds isn't weighing 10 pounds. You confuse praising Gary with challenging Ian's contention of a point that was addressed. They are the same thing to you. I think that your ability to provide me a reference is commendable, and you may not be disingenuous altogether. I don't know what this all bullshit is. Okay, so they're sitting there going time codes on videos. I mean, all this bullshit, all this minutia. And where is the subject? The subject is prove levers don't conserve momentum. That's what your obligation is. It will compare 2 weights and it will convert weights. Yes, that's certainly my argument. Okay, convert masses, it will convert momentum is the point. The lever converts momentum. Yes, that is my point. So that was it. There was a good point. I'm strictly speaking. And further elaborates that if a mass is resting on the lever and another mass is dropped on the other side, alluding to an impulse, the phenomenon is irrelevant because the phenomenon and imbalance occurs as the weight sticks to the lever and oscillate while they lose all the energy to friction at the pivot eventually. Right. I'm just I'm just saying there's nothing to argue here in my opinion. They're saying levers don't conserve momentum. I'm saying I don't see how they can't conserve the momentum. So anyway, do you have a point to make? He says after he posts all this stuff about the fact that, it's momentum, you're creating an impulse, the impulse, and basically I think somewhere in here he probably is also I'm pointing out that you're matching the acceleration and deceleration rates. You can make a something moving slowly, okay, that's heavy, and you can do the thing where it is now creating an acceleration that's much faster because the other side of the lever moves twice as much for every bit of movement on this side. So you can match the deceleration of the slow thing to the acceleration of the fast thing, and vice versa. You can put a fast thing in and create slow acceleration on the other side. So you're breaking what breaks the Newton's cradle, what makes the Newton's cradle incapable of taking energy from a light object and putting it into a heavy object, or vice versa. The lever enables. That's the point of the lever, is that it's this conversion device. So like gears and levers and hydraulics, they'll convert one momentum, fast, big V, little m, into big M, little v. That's the simple argument. They're conversion devices, and they're just converting big M's and little v's into big V's and little m's. And they have to do that conserving the momentum. That's the argument. That's my prediction. That's my assertion. And here they are doing all of this minutia about bullshit instead of directly showing that doesn't happen. Okay, thank you. Then you can help me understand and explain what is his point. Well, let's go further. Okay, Brozo did the experiment. Okay, the simple experiment partially. Okay, you have to say partially because he broke it by, he's rolling things and all of that kind of crap. But he obviously breaks a rule of angular momentum, a clear and decisive rule. Did Mindless Marbles tell him he's wrong? Did any of these people that show up say, Brozo, you're wrong? No. All right. Well, I guess mindless marbles did point it out because Brozo actually argued against mindless marbles on that point. So, sorry for that slight. All right, I'll try to give it a... Points are made in relation to arguments. In relation to the tangent, to this tangent, his point is that the fact you bring out of mass location on the lever and imbalance is irrelevant to the argument of lever conserving momentum. Thank you. Yes, let's just get to the subject. It either does or does not conserve momentum. So let's just answer that question. What are you a cult member? Okay, so that's the best he can do. Do you believe KE is a fable? So how is this relevant? He's arguing that the real point is to find out whether levers conserve momentum. My adherence to a cult or disbelief in KE does not correct your mistake I bring out in this video, nor does addressing my character prove anything as regard to the truth or validity. Not a cult member. So really, he thinks it's just totally unreasonable for any person to doubt that light is twice as bent by gravity. So even though Eddington said in his own journal, I wouldn't stake my life on these results, even though it was a 2 o'clock eclipse, you know, not the best, 2 something, even though it was raining like hell, no, those aren't good reasons to doubt. I mean, just amazing. Watch my video then. So he's just doing it again. Yeah. Oh, I've already explained it, you know, and my explanation is complete. Let's see. If you if you had made such a video, he would have already concluded. As I have demonstrated, he is responsive to arguments and reason. Yes, I am. Let's see. He would have conceded, and he goes, ha hoo. Yeah. I mean, really, it's just, this is so bad. I mean, he thinks I should concede. So Brozo did his video, got his perfect 1.4 results by completely ignoring angular momentum. Having a hollow object roll against a solid object. And I should be convinced by that evidence. That's your assertion, Ian. Okay. It just shows how little character you have. Okay. He's a fuck off here. Let's see. You sound like a nut job. Anyway, defending that dickhead deserves derision. What free energy? The free energy you're claiming exists. You're saying that the atoms and the velocity are not the subject. You're saying there's 1,000 times more energy, okay, in one person going 1,000 miles an hour than 1,000 people going 1 mile an hour. And I'm saying, no, those are both things I don't want to be hit by. I'd be scared to fuck. And so you know for sure which one you want to get hit by. You know for sure that there's 2 things coming at you, okay? 1,000 people going 1 mile an hour, okay, and one person going 1,000 miles an hour. Now, I would agree that it's pretty easy to know if somebody hits me at 1,000 miles an hour, I'm not going to like that. But I can also understand that 1,000 people is basically like a big wall, and it's going to fuck me up. All right. Let's see. What free energy? Are you stupid as him to deny inertia? So again, he keeps using this word inertia when it's already been over and over and over again stated that it's a synonym for mass. So again, no one's denying mass. We're denying that there's any reason to call mass inertia and make it sound like it is something. Mass is just mass. There isn't anything special about it. That's like denying gravity. No, it's nothing like that. Gravity doesn't have a synonym. As simple as inertia does, okay? What's the synonym for gravity? I could say momentum, but, If you agree with his ideology, then you can fuck off, boy. So again, this is What the hell is the real agenda of the Iron Gosling, right? What the fuck is, what's the little, the little worm up his ass? Okay, I see there is no discourse to be had with you. Have a wonderful day. Yes, that's pretty much, I would hope, satire. Thank you, but please think for yourself. So again, it's impossible. No one could ever agree, right, that there's no God, because to do so, you have to disagree with somebody, and you can't do that. So this is just such, these people's standards of logic and reasoning are so pathetic. Oh, evolution is just a cult. Okay. First, do you agree this video? So this is Mindless Marbles is now protracting the video argument. All right. Disputes Gary's false idea that momentum always has to be added positively. So let's see this. Any video we can see. Dr. S. Okay, so let's see what we got here.
Hear that?
Yeah,
Laughter means your donations are making an impact.
not really.
Goal. Determine how far each card travels per frame.
Okay, so this is just another cart, video. So we'll play it just because, why would he bother with this? When I can show the high school teacher's video doing the experiment and there's no evidence of the extra momentum. All right, travel and it's not even a video with, where they're reading text. I mean, what a waste of time that is.
Attempting to be as precise as possible. The ruler is irrelevant to this measurement, because we're measuring the amount of pixels themselves.
So this ought to be funny.
The first step is to import the video into Photoshop as a sequence.
We already saw this. Yeah, this is just how to measure frame rates. What the fuck does this have to do with anything? This doesn't prove the experiment is credible. Yeah, so okay, this is just a waste of time. Yeah, I mean, it doesn't prove that these frames are any good, that the blurry pictures are any good, or any of this crap means anything. So what the fuck is the use of this? I can just show I don't even have to do this because the frames are so much easier to see in the high school teacher video. I don't even have to go to this much trouble because it's so easy to calculate the frame rates, and they perfectly confirm the timing on her. She has timers. You don't even have to use frame rates, but she actually has timers, timing things. And it all works. So, what a pile of shit that is. So, wow, what a waste of time that was. That wasn't anything. First, do you agree with this video on how to calculate frame rates? Jesus Christ. If it is added up as positive quantities, then you violate momentum conservation. Well, in this case, and in other cases, there's no problem at all. Momentum perfectly works. So that's the problem with your experiments. And again, this is supposed to apply to any elastic collision. So frankly, why doesn't it work when there's no springs? Brozo couldn't get it to work on his air track with no springs. Okay, that's a concession Brozo made. It doesn't work without springs. All right, so... And now, and this bar's got it to work with the ricketiest, shittiest cars you could possibly imagine. So it doesn't make much sense. The variations of the experiments are evidence that apparently this isn't some phenomenon that's easily detected. Okay. If it is added based on direction, meaning opposite direction subtract, then momentum conservation is preserved. But I mean, it doesn't work if I plow a cue ball into two billiard balls on either side of it. I won't be able to create more momentum. So somehow it isn't consistent. Do you understand the word consistent? It has to happen consistently for you to form your theory. All right. If it doesn't happen consistently, it means your theory is incomplete. And it certainly doesn't demonstrate anything called squared velocity energy. Thus, Gary's idea that momentum is always positive is wrong. I'm saying any action in the universe is energy. and you can't be negative energy. That's what I'm saying. Now, I have pointed out that all the energy in the universe is created by expansions and contractions, and those have two dimensions to them. Nothing in space by itself could possibly just contract in one direction. It has to contract in both directions, and it has to expand in both directions. So I have pointed that out, which depends on your choice of coordinates. So the argument is that there's two kinds of energy in the universe. Stream energy just moving in one of those directions from an explosion, and the explosions themselves. There's two sources of energy. The ones that are already in the universe and the ones that haven't been put into the universe yet. The free energy versus the stored energy. When the stored energy is freed, it's freed in both directions. Alright, I will make an honest effort to explain as much as possible if you wish, such as context of the video I posted. In the video, so he's all the way back to arguing one specific example of the carts. So I could just keep showing the Professor Lewin video. I did. Alright, I requested that somebody explain to me how the two carts could have a 2-to-1 mass ratio. How it is possible that looking at the two carts, how you could explain that they actually had the weights claimed by Professor Lewin. Because the one cart doesn't have twice as much of all the attachments. And in the case of the clay, it doesn't have any. So it's missing 4 pieces of clay. Not just 2, 4. But he won't respond to that argument. Alright, your description does not match the events that take shape in the video at the video claims draft science prediction was 15% off and fails to state the prediction being challenged. While you are making a point about total momentum of a system after collision. Well, again, there's no way to even trust the experiment is the point, but whatever. Sort by newest first in comments here. YouTube comments designed is so frustrating. The reference keeps getting censored. Okay, whatever that means. Got it. His explanations are too sloppy and seem to characterize the opposing argument while butchering it in the process. Okay. I see what you are saying. Initial velocity of mass 1 is 100. Upon collision, it makes it negative 133. While the 2, so I don't know why he's agreeing, mass object gains a 66 is 166, 60% the initial velocity of the one mass, while he should instead replace the one mass velocity by 33% of his own velocity, that is, well, that's what I'm saying, 33%, and give the rest 66% of the velocity of the two mass objects 66, is mischaracterizing the collision from the equation. So I don't know what I mischaracterized, but whatever, who cares? I don't think he understands them. So that doesn't, whatever. Not that I do either in any intimate matter, but playing with it I can determine upon impact it predicts one mass velocity is 1/3 its own starting velocity. Yeah, this is all, I don't know why you're saying I've mischaracterized anything. We're starting with 100 just to start a standard number, and we're saying 133 goes in one direction and 33 goes in the other direction. What's so complicated? We now have a total in the universe of 166. So we started with 100, now we have 166 of stuff moving in the universe. While two mass object is predicted to having 2/3 the initial velocity of the one mass object. Yes, so I didn't mischaracterize anything, you fucker. I think he is being fictitious as saying, see, you believe in free energy. I know. I'm saying that motion in the universe is always real. There's no un-energy. But whatever. To sort this out, I need further investigate this specific objection. So he apparently, this Alexander Zaptia guy, doesn't know about the free energy experiment, the free momentum experiment. I mean, there's so many videos on that subject. Dear Marbles, what would be predicted speeds of the 2m collision into one mass is going to be similar to the lever, only giving the half mass 1.4. So isn't that interesting? So even though it has twice the energy, he's saying it's only going to have 1.4, the compression of the spring. So somehow twice the energy is going to be 1.4. Okay. So obviously he doesn't think a spring's an energy detector. It's detecting something else. You know, it's not detecting the energy. So, what is this? Draft Science replied and conceded that the specific detail he did not know. You must have missed it, because you made multiple videos, continue to hammer and pretend he has no understanding of the phenomenon. And you came up with the arrogant little insults as if enjoying a superior position, attempting to belittle. Petty, childish behavior, in my opinion, while simultaneously ignoring the argument he is challenging you with. So now he's looked it up and found out that, oh yeah, I didn't mischaracterize anything. So anyway, so spinning things, that's the, oh well, this is the angular momentum video. So I don't know why he's going back to the angular momentum subject. That is weird. Okay, it really doesn't have anything to do with what you're arguing. So that's interesting to me, the fact that I don't know levers were this sensitive to where. Okay, so this is about the spinning lever part, and I conceded that, yeah, I never looked into how levers function, and I never thought there was any difference where I put the masses, you know, whether the mass is on top or hanging or in the middle. And apparently if it's in the middle, it's not a very good balance anymore. Yeah, no worky, something like that anyway. So I don't know, all of this crap, Jesus. I mean, it's just such a simple argument. They don't believe that all these devices conserve momentum. So all of this idea that there's any law in physics that you have to conserve momentum, they're arguing it's a big fucking lie. So they ought to just prove that all these devices do not conserve momentum. And so that's what Ian Gosling is saying. He's saying I'm going to have two of the same momentums hit a spring. Okay. Now the only catch is, again, there's a constant force that's also hitting the spring, hitting the masses. So you have to subtract the constant force out and just get the impact momentum. So if you did it horizontally, again, that would be the better experiment because it takes gravity out of it. But regardless, you can do it vertically, just understanding you have to take the constant force out. And he says he's going to prove, okay, that springs don't conserve momentum. That is, they don't detect momentum. They don't store momentum. And he's apparently stuck on this 1.4 number. So apparently he's going to get this 1.4 result. And we'll see what the number is after you abstract the weight from the weight. So you're going to get a measured weight. You just subtract the actual weight of the object, the mass weight, and then you subtract the mass weight from the two numbers. And the two numbers should be the same because the spring can only see momentum. And again, why they argue that something with twice the energy only compresses the spring 0.4, that's a little hard to figure out. It's only 0.4 more. Yeah, it's missing the 0.6. Okay, why is it missing the 0.6? Alright, so that's probably enough. Yeah, we're well over an hour, so I probably shouldn't have gotten into that little minutia stuff. It's kind of a waste of time and such. So anyway, so enough of a video, right? I mean, I've stressed the point like 6 times in this video. It's about proving that there is no conservation of momentum. I mean, it's such an obvious argument. The difference between mv and mv squared, obviously the square is huge, it's giant. And any time I do a transition, I move energy from a big thing and I put it, I actually get all of its energy into a small thing. I'm obviously going to create a huge inequity between momentum and kinetic energy. They can't give anywhere near compatible or equal results. Momentum says the bullet and the gun recoil have the same energy. Kinetic energy says one has 1,000 times more energy. I mean, it's a huge difference. They're not compatible theories. If you say you have to conserve momentum, then you're basically saying you can't be conserving kinetic energy. It can't mean anything because it's a free energy then. You can't escape the consequence that you can conserve 100% of the momentum, that is, lose no energy, and still, okay, do a bunch of work. But we'll see. Like I said, there's momentum could be an incomplete theory, but mv squared is a completely nonsensical pile of rubbish. The fact that they say it, okay, that something could have the same momentum and be 1,000 times, have 1,000 times the energy, those two phrases can't really sit together and be reasonable. You can't say it has the same momentum, but that one has 1,000 times more energy. I mean, it just doesn't make any sense. Okay, enough said, frankly. Till the next time, and such and so forth and whatnot.